Hi everyone, welcome back. In this video we'll continue working on the same geometry from last time. We already opened it and have it just right where we left off. So today we'll use a field for pressure loading and we'll create the constraints at the locations for the washers. In the second part of the video we'll analyze it and see the fringe and the displacements for these pieces with the pressure that we'll establish right now. First, we'll change the view to wireframe and we'll go to apply erase. So first we'll select the solid. This means that we want to select all the faces and all the points, and we will delete all the, for now we'll delete all the elements. So we'll go to erase all and then we'll plot the solid only the geometry. Now we'll go to geometry to create some points using the arc center method, and we'll turn off auto execute for now. First we want to zoom in a little bit so we can select the curves. And now we'll make the points bigger. Now the arcs we want to choose are this one and this one right here. And we have the arc centers. And now we'll create a coordinate system. So we'll go to object coord, method 3-point, and the type of coordinate system is cylindrical. And the origin will be right in the center of this circle, so the point we just created. The point on axis 3 will be the second point we just made, and the point on plane 1-3 will be this one right to the left. So we'll click apply and we have our new coordinate system. Now we want to create the field. So we'll go to loads and boundary conditions, and here in LVC fields we'll select the spatial one. The method we'll be using will be PCL function and we have to name it. So we'll choose the name sine theta. The field type must be scalar and the coordinate system will be real. The coordinate system we'll be using will be coord2, so the one we just created. And here we have our variables, and the scalar function is sine r of t, this variable. And we'll click apply. Now we have our field and we'll create the pressure loading. So here in loads boundary conditions we go to element uniform and pressure. We have to name it again, so we'll choose pressure load. We'll go to input data, and here in the load or VC set scale factor we'll enter 1000, and here in the pressure box we'll have to select spatial fields from down here and select sine theta, and we'll click OK, and then we can select the application region. Here we want to make sure that we'll select these 4 top faces. So we want to make sure that we select the 4 of them. We can add them and then we can click OK and we can apply the pressure. We can see that it has been uniformly distributed on all the 3 points. We can zoom in a little bit more so you can see that the numbers are here. Now we'll do the constraints, so we'll go back to load VCs and then we'll go to create an object displacement, and the type will be nodal. So the new set name is fixed at washers, and input data. In translations we'll enter 000 and we'll click OK, and then we can select the application region, and we want to make sure that we are selecting actual surfaces because these are kind of hard to see, and we'll select the smooth shaded view for this one because we have to actually select these surfaces right here. We'll select one by one. These are 4, And finally we'll select the third face. And then we click apply and we have our constraints. Now we want to plot the loads and the boundary conditions. So here in loads, we'll go to action, plot markers. We have to make sure that the assigned load sets are here, and the group filter must be current viewport, and we'll select groups, default group. So we'll select both, and then we'll click apply.